So I am going to welcome everybody to this webinar called The Real Reason Greenland Determines Our Fate. I am Margaret Williams. I'm a senior fellow with the Arctic Initiative at the Belfer Center for Science and International Affairs, which is housed in the Harvard Kennedy School. This webinar is a result of collaboration between three organizations: the Arctic Initiative, where I am based at the Belfer Center, the Woods Hole Oceanographic Institution, and Rethink Energy Florida. I'd like to thank my colleagues at those organizations for helping to put this together. We are so glad to see your interest in this topic. We have over 500 people registered for this webinar. Most of you are from North America, but quite a few people are calling in from Europe and other parts of the world. Our plan for the next hour is that we will devote the first half of the webinar to our experts, and then you will have a chance to ask questions by putting your questions in the Q&A function at the bottom of your screen. And I'll ask you to also send your name and affiliation. If you're interested in a recording and watching the presentations after this is done, we will send the recording to all of those of you who have registered. So anyone who's on this will get a link, and you can go and watch this again and again and share it with your friends. Finally, I will mention that we're going to put a few resources on in the chat for you to look at later. And I'll draw your attention to a very recent op-ed, hot off the press from the Tampa Bay Times, written by one of our co-hosts, co-written by one of the co-hosts, which is Rethink Energy Florida. Really good piece. So now onto our subject matter. There has been a lot of attention paid to Greenland lately due to President Trump's proposal that the US should purchase Greenland. His idea misses the mark in so many ways. First of all, this goes against the very wish of the people who live on that island, the Greenlanders. Greenland is an independent country, which is part of the Kingdom of Denmark. And as the Greenlandic Prime Minister has said, Greenlanders do not want to be Danish. They do not want to be American. They want to be Greenlanders. So we need to respect that. Second, this proposal is a violation of indigenous rights, human rights, and the rule of law. Third, this concept of buying Greenland has jeopardized very solid, good relations that have existed for decades between the US, Denmark, and Greenland. Greenland, and as Senator Lisa Murkowski has said from Alaska, and yesterday during a Senate hearing in the Committee on Commerce, Science, and Transportation, Senator Andy Kim said that Greenland is an ally, not an asset to be acquired. Finally, and this is where we're getting to in our next half hour, is all of this buzz has overshadowed another really important issue, and that is unfolding in Greenland as we speak, and that is that Greenland is the Northern Hemisphere's home to the Northern Hemisphere's greatest volume of land-based ice. As global temperatures rise, the melting of the ice sheet will have a dramatic and severe impact on every single coastal nation on the planet. So I'm going to introduce our speakers. They will give us a factual overview of what's happening with respect to Greenland's ice sheet, and then we'll hear a bit about the possible response that the global policy community could consider. You can read more about our experts on the website where you registered, so I'll just give a quick overview of their biographies. We'll first hear from Dr. Sarah Das. She is a scientist at the Woods Hole Oceanographic Institution. She is also a faculty member of the MIT Woods Hole Oceanographic Institution joint program in oceanography. Dr. Das has led 20 multidisciplinary expeditions to Greenland and Antarctica, and she continues to uses her expertise to train future scientists, advise policymakers, and work with many fellow polar experts in forums such as the Polar Research Board of the National Academies of Sciences. Next, we'll hear from Mr. Rafe Pomerance, who is a senior policy fellow at the Woodwell Climate Research Institute. He has been a climate advocate since the 1970s, working with the World Resources Institute, the League of Conservation Voters, and many other non-governmental organizations. I first met Rafe when he was Deputy Assistant Secretary of State for the Environment and Development under President Clinton. And then we worked together through Arctic 21, which is a network of organizations focused on communicating the science of unraveling the Arctic. Rafe's work was the focus of a New York Times Sunday Magazine article, which you may have seen several years ago, entitled Losing Earth. So thank you both for taking time to speak with this audience today on a very important topic. And Dr. Das, I'm going to turn it over to you and your presentation.
Great. Thanks, Margaret, for the invitation. And thank you to the Belfer Center and all the partner organizations for helping to elevate this really important topic. I'm going to share a presentation with all of you that I hope will help you understand what's happening in Greenland and why there's a lot that we need to be thinking about, as Margaret alluded to. I want to start with some take-home messages. These are the 4 important points I hope to get across in my presentation. And so if you take nothing away, hopefully you will remember these things. I'm going to go through each of them. First, the loss of the Greenland ice sheet today is unprecedented. I'm going to show you some of the evidence for that and how we understand that. Second, Greenland ice behavior is dynamic, complex, and high stakes for all of us around the world. So I'm going to hopefully help you understand also, as glaciologists and polar scientists, how do we go about understanding not just what the ice is doing today and in the past, but how we might make better predictions in the future and how the ice sheet responds to climate change. What happens in Greenland does not stay in Greenland. What happens in the Arctic does not stay in the Arctic. The reason that Greenland is so important to all of us, no matter whether we live on the coast, in the United States, in Asia, or in the heartland of the country, where we're growing the crops and important food for everyone. Greenland is connected to every part of the Earth. And finally, we're going to be talking about some heavy topics today and some projections that can feel overwhelming. I hope to also share with you and also be part of an important conversation with my partner here on the panel, Rafe. It's not too late to change the outcome. The future is not written. A lot of what we're going to be talking about is dire. There are huge consequences, but the decisions we make today, the choices we make tomorrow, make an important difference. I want to just spend a minute or two providing some context for where we are in this moment before I dive into Greenland. 2024 is the warmest year to date on the planet since we've been making instrumental measurements in the pre-industrial period. The last 10 years on the planet were the warmest 10 years to date. This really sets the stage for the changes that we're seeing in Greenland and the dynamic response Greenland has had to this warming. And you can see that this warming is distributed almost around the entire planet in this spatial view, which is showing a temperature anomaly since the 1950 average. Oops. This warming is not due to natural causes. It is on the back of the fossil fuel consumption that has really driven worldwide economies and growth in the last, especially 150 years. On this chart, I'm just showing the rise in fossil fuel consumption on an annual basis, starting in the mid-1800s. And I've annotated it just to show what this means in human lifetimes. The beginning really in this rise of this global emissions and fossil fuel use was about the time that my grandparents' grandparents were born. Obviously much farther back in time than I can remember, but not so far ago that it seems impossible to know that I knew my grandparents who knew their grandparents. You can see as we move through the 20th century, around the time that my parents were born, mid-century, many of you in the audience may be of a similar age. We're still at fairly low levels of annual consumption. When I was born, and especially when my kids were born, we're starting to see a dramatic increase in global fossil fuel consumption. And it's the greenhouse gases from these emissions that are driving this warming that we're seeing across the planet. That's just a fact. We can talk later on about whether we should be making changes to this, but I think it's really important to connect the dots here to see how this rise in fossil fuel use has led to warming. And it's that warming that's causing Greenland to melt faster and faster. We're now taking a similar view in time, again, from 1850 to the present. And we see how this rise in greenhouse gases that's keeping the planet warmer and warmer is expressed in warming in time now, not just on land, but also in the ocean. So you see about the mid-20th century, you start to see a rapid rise in the average land temperature, as well as the average ocean temperature. In fact, the ocean is absorbing close to 90% of the excess heat that we're pumping into the atmosphere. And that turns out to be a very important piece of the story when you talk about changes in Greenland or Antarctica, which won't be the focus today, because it's not just the warming air, but also the warming ocean that is leading to increases in ice loss and the eroding of these glaciers over time. So now to talk a little bit more about Greenland specifically. One thing I think is an important point to make is that it's really been in my lifetime that Greenland has changed from a relatively stable state where its ice sheet is what we call in balance. So the snow coming in is matched by the ice melt and the calving going out. That's really changed in my lifetime from this stable balance to a rapid and accelerating decline. And what's shown here in the blue curve, now looking back to about the early 1970s, is this relatively stable state. You see this flat blue curve at the top of the screen. And then around the 1990s, you start to see this rapid sort of plunging decline. And this is indicative of what we call the cumulative mass change in gigatons of ice. So year on year, how much ice from Greenland is being lost and how that is accumulating year after year and resulting in sea level rise. And this is taking us all the way up through the present and is a process that is ongoing. Again, in response to this warming, not only of the atmosphere, but as well of the ocean. I'm going to now zoom in to a slightly higher resolution view of that same mass loss process in Greenland to start to give you a picture of what that looks like across the entire continent. Greenland is a massive island. It's covered by an ice sheet that's over 2 miles thick in its interior. I've found almost impossible to help people understand how large Greenland is and how much ice is held up in it. But this will give you a sense for where the ice loss is most dramatic. So I'm going to play an animation, and what you're going to see in the blue line is this mass loss again, now starting in 2002 when we have very good satellite observations through to 2022, which is as far as this animation goes, but this loss continues. And you'll see on the ice sheet image on the left, colors start to fill in. The darker red colors indicate where you have the most ice mass being lost over time. So you start to see that it's around the edges, the margins of Greenland, where most of this ice loss is occurring. And that's because the edges of Greenland are where the ice is lower. And so it's exposed to warmer temperatures in the atmosphere. It's also around the edges where you have large ice streams or glaciers that are coming into contact with the warming ocean. And as this warming ocean interacts with the front of these glaciers, you also have things like calving, large pieces of ice breaking off. And that has a ripple effect where it extends farther into the interior of Greenland and draws that ice out more quickly. And so this fingerprint that we are left with at the end really illustrates that around almost all of Greenland, ice is being lost year after year. And it's not being replenished at a rate that keeps it in balance. And so it's this overall ice loss that's leading to sea level rise. I'm not going to spend a lot of time on this figure. I could spend an entire semester teaching you about the fundamentals of ice sheet research and how ice sheets work. But I want to just show this figure quickly because we're now taking a cutaway view at the ice sheet. So I mentioned how the interior of Greenland is about 2 miles thick. And what we're really looking at here is all the different kinds of processes and scales of processes that as scientists, we need to understand when we're trying to understand why the ice is growing or shrinking and how it's changing over time. So we need to measure things like the rate of snowfall in to the top of the ice sheet. We need to understand melting around the edges like we showed in those satellite images. We need to understand how the ice is moving. So ice deforms internally, it's squished under its own weight and it's pouring out towards the edges of Greenland. It's also sliding along the base. When you have water that's getting through the ice sheet, the ice is actually sliding along the bedrock below. And then again, you have these processes at the edges where the ocean comes into contact, breaking off pieces of the ice. So all these pieces need to be summed up together. And these are things that scientists are doing important work on. I want to show just a few pictures here. I've done a lot of work in Greenland As Margaret mentioned, I've led over 20 expeditions both to Greenland and Antarctica, and we're really trying to understand what's happening. We can put out instrumentation, we can collect samples, we can do all sorts of important work by being on the ground. And I just want to illustrate, what does melting Greenland look like when you're in Greenland? So this is an example of a large meltwater stream. Two of my colleagues are up on the edge of this canyon, just to give you a sense of the dramatic landscape and what these large melt features look like as Greenland is melting around its edges. This is another expedition we led to one of the fjords up around a calving glacier that's pouring off the Greenland ice sheet. And here we're working with some new instrumentation to try to understand how the warming ocean interacts with the ice front and how these two things play together to also eat away and carve away at the melting ice. But Greenland is not just melting on the surface and at the edges where it meets the ocean. It's also melting high in the interior in places where it's still cold enough that this meltwater is refrozen within the snowpack on the surface. But this allows us to look back in time and see how unprecedented the rapid rates of warming and melting are today by using tools such as drilling ice cores. We can peer back in time. I'm now showing an ice core from near the interior of Greenland, where we can look, these darker bands are actually showing us where ice has melted and refrozen into the firn. And this is occurring over wider and wider areas and more frequently. The main point here is that polar ice loss is going to continue to accelerate, and these large ice sheets this loss is really irreversible. So as more of Greenland melts away, as more of Antarctica melts away, driven by this warming air and atmosphere, even once we stabilize temperatures, and I'm confident that we will, these ice sheets will not grow back. So we are committing future generations for hundreds, thousands of years to the amount of ice loss that we are driving today. But as I mentioned at the top, this future Greenland melt is not written in stone. Our choices and our actions today have an enormous part to play on what future scenarios will look like. I'm showing here on the left, this is a plot of future Greenland melt projections from the 1990s. The gray line is observations. And then these three colored curves are under different emission scenarios, what to mid-century, and then on the right-hand panel to the end of the century, what the different sea level contributions look like if we reach lower, middle, or higher emission scenarios. I'm not going to focus too much on the exact numbers here, but I want you to understand that the difference between, for example, the low and the high emission scenarios is about a doubling of Greenland melt from mid-century going forward. So these are the kinds of tools we can use to help us understand the implications for the energy and emission decisions that we're making. Of course, there's many other global impacts of melting Greenland ice sheet as well. I'm not going to focus on these here, but it's important to understand the context within which melting Greenland fits in the global scale. So freshwater can alter ocean currents around the world. It can disrupt marine ecosystems, which play a really important role, not just in fisheries, but also in producing, for example, the oxygen, the air that we all breathe on Earth. The way that Greenland interacts with the Arctic climate system can change things like albedo, which can amplify global warming. The Arctic is actually now warming 4 times faster than the global average. It can also alter things like the jet stream, which can shift weather patterns and lead to things like droughts and floods and increased forest fires. So I hope I've given you a little bit of picture about what melting Greenland looks like. As I mentioned, though, what happens in Greenland doesn't stay in Greenland. So I think of a picture of melting Greenland that looks like this, but I would also like to suggest to you that another picture, to me, of melting Greenland looks like this. And this isn't maybe what you're expecting. This is a picture I took last fall in my hometown of Situate, Massachusetts, on the coast a little bit south of Boston. And I'm using this here to illustrate that Greenland can seem far away, and the melting and the scale of melting can seem enormous and almost abstract. But we are already feeling the implications of this Greenland ice melt in terms of sea level rise and flooding and inundation around our coastlines. And I'm not even immune to this. This is my hometown. This is a parking lot. It's part of our main business district in town. It's right on a beautiful harbor. And the thing I like about this picture, while I don't like the fact that the parking lot is completely inundated with seawater, not even on a particular stormy day, this is more of a very high tide, is that all these nondescript things in the background help to for me to help illustrate how connected rising sea level and coastal inundation is to all of our lives and all the different pieces. So impacted in an event like this, which is occurring more and more rapidly, are people's residences, small businesses. We have a Coast Guard station, the harbor master's office, the town gazebo where we gather in the summer together. We have fishing fleets and public docks where people access the water. So all these things are impacted when we have rising seas and increasing coastal flooding. Just to drive home the point even farther, here's a projection that the sea level team from NASA has made for the city of Boston. And you can go on these, use these tools and pull up many, many cities across the United States to see what projected flooding days will be in the future due to sea level rise scenarios from increased melting from Greenland, as well as other causes. And what you can see on the x-axis is in 2020, Boston experienced about 20 flooding days per year. So that's less than 10% of days. I will point out in the 20th century, this was usually around 5 or fewer per year. So 20 is already fourfold what we were seeing in the 20th century. But now let's look out mid-century. We're projecting flooding days in Boston to be about 100. So that's almost 1 in 3 days. The end of the century now, and these are middle range sea level rise scenarios, it's over 300 days. That's every single day. So think of the impacts that that has on livelihoods, infrastructure, health, everything when you are a coastal city. Massachusetts has risks not just in Boston. Of course, towns across the state are facing this. And we've been real leaders in the state at being prepared for this, but I would argue that even with the best preparation, the financial costs are so incredible that even a state like Massachusetts that is very forward-thinking this is going to be really hard-pressed to come up with the finances to solve these problems. And I know certainly living in a small town on the coast, it's well beyond the means of what we're able to handle. So some statewide estimates have been that damage to coastal structure by 2070, which is not that long from now, could exceed $1 billion per year. And of course, this is not just happening in Boston or Massachusetts, but around the country. We start looking at sea level rise scenarios. And the main point I want to show in this figure here on the left, for over about the last century, 1920, you see a relatively modest, I would say, rise in sea level up to about the present, and this black line. And then you start to see these colored lines sort of shooting off into the distance. And there's 2 points I want to make here. One is there's not a lot of spread between these by mid-century. So we're expecting about a foot of sea level rise additional by 2050. But it's after that point in time where you see this wide range of average sea level projections that, again, really are intimately tied to these different emission scenarios that we're facing. And that's where it makes such a difference to a place like Greenland. How much warmer are we going to let the planet get? How much more ice are we going to melt? And are we ready to face 6 to 10 feet of sea level rise? I would argue we're probably better off trying to limit that as much as we can. Of course, there's many other risks around the country. There's 90 million people in the United States live in coastal communities, and our infrastructure is at dramatic risk from coastal flooding. Everything from housing, education institutions, public safety, health, industrial sites, energy, government, nothing is immune. We have hundreds of thousands of these assets and almost 100 million people that are at risk.
And Sarah?
Yes.
We're coming up on 18 minutes.
Great. There are, of course, also enormous fiscal risks from climate change, and these things all play together. As you have damage in your assets, you're going to reduce your tax base. You're going to have to spend more on protection, and there's going to be these steamroll effects on budgets. I'm almost done. And then we have health risks. It's, I think, also very important to see the mounting risks that flooding, coastal flooding, and climate change more generally is leading to public health. And this is becoming a more and more important part of the conversation. And finally, we have enormous defense and homeland security risks. Many studies have been coming out recently showing how imperiled our US bases are, both in the continental United States as well as around the world. For example, in the Pacific, many of the atolls where we have important military installations will be uninhabitable in this century. And to zoom even further out, as I finish up here, of course, there are global risks. So we have hundreds of millions of people around the world that live less than a meter below the high tide line, more than 500 million people that live within the high tide line of these higher projections, which are the paths that we are on. And I'm going to turn things over to Rafe now, and I just want to sort of end on this note, which is, again, to drive home the point that where we are, even though we're at the warmest point in history now, here in 2024, we have many scenarios laid out before us, and it's our choices that will impact our global temperatures and, in turn, melting of Greenland and our sea level rise. And I'm going to leave you on hopefully a slightly hopeful note, which is that worldwide, study after study shows that majority of people believe in climate change, think it's a serious threat to humanity, and want us to act. Thanks very much.
Thank you so much, Dr. Das. And now to take it into the policy realm, building on that fantastic and very sobering scientific presentation, Mr. Rafe Pomerance will give it to you now.
Thank you, Margaret. Thank you, Sarah, for that great presentation. It was terrific. And you covered so much appropriate, I was going to say ground, water. I'm going to make just a couple of quick opening comments and then talk about this policy initiative that I'm working on with colleagues called the Upper Limit for Sea Level Rise. You know, we're at a historic moment, and this Greenland issue comes right into that. I mean, Trump and his allies are cutting the heart out of U.S. climate policy. We don't quite know all the outcomes yet, but the direction is that the United States have become an absent player in the climate world. At a moment when all this data on Greenland, for example, is coming forward. So you have sort of Trump pulling the United States out of the climate policy world, therefore accelerating the temperature rise in the US and globally, and at the same time wanting to buy Greenland, which is this source of potentially enormous amount of sea level rise. So all that sort of comes together in an interesting way, because this interest in Greenland gives us the opportunity to focus a lot of attention on the ice sheets, in particular Greenland, but also Antarctica. It's sort of like a public relations opportunity to tell the story, because Greenland has more attention now than it's ever had. All right, just a little introduction of my career here. I started my work in the late 1970s on climate change, when I described the situation as we were in an empty room. There was no interest, no knowledge, very little work going on. I mean, there was plenty of work in the scientific community, but none of it was in the policy community. And in the next decade, I was able to work with lots of colleagues to arrange a set of congressional hearings from 1985 to 88, which, due to the great work of scientists like Jim Hansen and others, brought the issue to the front pages of the major papers and the cover of various magazines. And that period really triggered the formation of the IPCC, the negotiation of the Framework Convention on Climate Change, all of which took place in the following years, and even much of that under the Reagan administration and the George H.W. Bush administration. That period is captured in this, I think Margaret mentioned in Nathaniel Rich's piece, which was the entire issue of the New York Times Magazine, called Losing Earth. So if you'd like to know more about that, it's, despite the fact that I'm in it, it's a good read. And I'll then jump to a period in the earlier part of the century, 2007, 2011, 12, when the sea ice numbers began to jump. That is to say that the loss of sea ice was accelerating in dramatic fashion because the polar region was warming so fast. And that led us to the formation, which Margaret mentioned, of Arctic 21, a network, still exists, devoted to communicating the unraveling of the Arctic, which includes the glaciers, the ice sheet, snow cover, particularly in the spring, sea ice, and permafrost. And permafrost is huge feedback of carbon that will ultimately end up back in the atmosphere. So now, with colleagues, the world is not making sufficient progress on climate change, not making sufficient progress on lowering the rates of emissions, not making sufficient progress in holding on to the global temperatures. And we came up with this idea that the world right now has one metric, which is global temperature. That's what's in the Paris Accord. And we thought that adding a second metric to that could motivate policy in a big way. So we decided to put a proposal on the table, which we call the upper limit to sea level rise. Let us establish an upper limit. How high is too high? Where will we allow the world to go? And we thought that adding such a second metric into the climate world, I mean, on a global basis, might drive policy. And we used sort of in our minds, we worked this out in Florida, where we thought, ask your public official, how high is too high? How far are you willing to let this go? And which then would provide public officials with the rationale to really take on the more radical and important policy measures, because they could point to sea level rise impacts, which Sarah laid out, which affect so many millions of people and is so costly. So the idea was move beyond the global temperature regime, I mean, as the only metric, and establish a second metric, which we thought might move policy. And in that process, we started to try to sell this in Florida. We're still selling. It's still in the early stages. But we realized that there's the global potential for this. There's a big market for allies and others with this idea. And we ended up making various presentations to delegations at the General Assembly special session in September. They had a full day on sea level rise. And we continue to try to find allies. Now, I give you an example here that Sarah's presentation on the state of Massachusetts is impressive. So what might the officials of Massachusetts do in addition to what they're already doing, a lot of great work? We think they could consider adopting the idea of an upper limit to sea level rise. And then that's an overall comprehensive proposal to carry this forward, in which they could build allies with other governors, not with the federal government of the US right now, but potentially other nations. Because it's obviously in the long-term interests of Massachusetts to reduce the rate of increase as much as possible. And in order to do that, you need global action. In order to get the global action, you need all kinds of allies. So that's the idea for the upper limit, to bring it even to the negotiations that occur annually of the climate, of governments involved in the climate issue, and establish an upper limit to sea level rise. That debate, if it took place, would then, it would sort of, Sarah's presentation would be the governments would have to stare the potential impacts, right there on the floor of the convention and negotiations. And we think that that could move policy. It gives, as I said earlier, politicians a rationale and even protection for taking strong measures. Now, the definition of the upper limit is sort of interesting that we came up with, because You can't stop sea level rise right away. There's too much warming built into the planet at this point. But what you can do is lower the rate of increase, as the graphs that Sarah presented demonstrate. There's different paths forward in the world, and if governments manage to get down to the lowest rates of emissions, you then get the lowest rates of sea level rise, for starters. And we again think that the sea level rise can motivate the kinds of changes that could drive emissions down. Global temperature is a great metric, but it's pretty obscure for most people. They don't know what it means, 1.5 degrees centigrade. What does that mean to me? But sea level rise means something important to the hundreds of millions of people ultimately who are affected. The second part of the definition, so the first part is lowest possible rate of increase. The second part is to stop the disintegration of the ice sheets, and A, Greenland, and B, Antarctica, because there is so much potential sea level rise. It's catastrophic if we allow global temperatures to continue to rise, and ultimately you start to lose major pieces of Greenland and Antarctica. The consequences are devastating on a global basis. So we wanted to give more prominence to the ice sheets. And ironically, or surprisingly, Trump's desire to buy Greenland has offered up a chance to put the spotlight for a totally different reason on Greenland, which is the fate of its ice sheet. Third, we wanted to establish decadal goals for the world. Hard to do, but we need goals to shoot for. And finally, we have to build resilience. And as I said, the policymakers can build alliances with other jurisdictions that are adversely affected. Okay, final discussion is about this Greenland moment. You know, Trump tried to, he put it out there 5 years ago. One thing you can say, didn't forget. And, but now he's done it again, but he's accompanying it with the destruction of vast parts of the government. We don't know how big, where the money will go, but his agenda is to eliminate the alternative energy initiatives and industry, to stop the subsidies for buying electric vehicles. Across the board, he wants to put an end to all that. Now, so as I said in the beginning, if you juxtapose this sort of political focus on Greenland, but what the actual big issue is on Greenland are ignored, which is the ice sheet and its fate, 23 feet of sea level rise ultimately. So we want to bring that to the attention of people who care. And we now have, however, the sea level rise increasing, the temperature increase, and Trump abandoning the whole effort. And this is just a very difficult moment. But if we use the Greenland issue properly and do the education around it, our intention is to bring people back to the climate issue in a significant way, and using Greenland as the hook, because Trump has given Greenland so much attention. So we can take advantage of that
Yes.
in trying to put things back together. Sometimes I think about 2029. Isn't that the next presidential term start? Am I right? You know, when is it that we can shoot for to put all of it back and
Yes.
accelerate the U.S. Effort? Now, in the meantime,
Yep.
of course, what's that? Am I done?
Oh, yeah,
I'm
you're
done.
wrapping up soon, right?
I'm wrapping up. Absolutely. I would just say that leadership today can be with many of the U.S. states and other governments, right? We're not without leadership, not without policy-making opportunities, but Greenland and its impacts of the loss of the ice sheet can be a real driver of all that. So I'll stop there.
Okay, thank you so much. And you use the term radical, that addressing this, it requires radical policy, but it's really radical to ignore it, all of these incredible changes,
Right.
by
Agreed. Agreed.
gutting science and ignoring the facts about what's happening in our Arctic. I wanted to ask you, Sarah, Dr. Doss, would you just like to briefly comment on Antarctica and other factors that are contributing to sea level rise? Because clearly, if we're thinking about the global sources of sea level rise, Greenland is a major source, but there are other contributors as well.
Yeah, that's a great question, Margaret. Thank you for that. So the focus here today is on Greenland, which is important and as it should be. But of course, when we think about something like sea level rise, we have to think of all the different dimensions that go into why the size of the ocean is changing and why the sea is rising. And it's rising differently in some places than other. And Antarctica is the other big wild card when it comes to melting ice. So Greenland is now the largest contributor to sea level rise, but Antarctica holds 10 times the total amount of ice that Greenland does. And it's starting to sort of awaken from its slumber, so to speak. So there's a lot of effort being spent right now to try to understand a particular part of Antarctica called West Antarctica, where much of the ice sheet actually sits below sea level. And it's the part of Antarctica that is now losing ice the fastest, speeding up the fastest. And there's tremendous concern that as, in particular, the oceans around Antarctica warm, again, the ocean's taking up the brunt of so much of this excess heat. This warm ocean is eating away at the underside of West Antarctica and can just put some processes into play. So that's really an important thing for us to be following. And the other important factor to consider when it comes to sea level rise is, of course, the thermal expansion of the ocean itself. So because the ocean is absorbing so much heat, its volume is changing and it's getting bigger. So you have to think about all of these pieces together, not just Greenland in isolation, because they all come together.
Thank you. Sobering. I'm probably going to keep repeating that word, but I'm going to go to the chat because we've got questions rolling in. And I'd like to thank Seth Borenstein from the Associated Press for this question. I think maybe both of you would like to answer it, but the question is, could a Trump takeover of Greenland change, as in worsen or even ease, the melting of Greenland? And if so, how? Or does it only affect does the only effect U.S. policy could have on Greenland melt be in the big picture of overall human-caused warming? If it worsens melt, can you try to quantify? I think, Rafe, you were getting at this a little bit before, but
well, it's sort of the first part of the question is Sarah's. I mean, can the takeover change, I think, the rate of warming in Greenland somehow? Do I have that right?
Yeah, I guess is there any change which is still unrealistic, but the concept of the U.S. taking over Greenland?
I can take a stab at the beginning of that and then maybe hand it over to Rafe. I was really interested in the Senate hearing yesterday, and I think it's important for us all to understand that, the United States has had a strong presence in Greenland, since World War II, even before then. And when I work in Greenland, I usually am traveling to Greenland on, say, an LC-130 with the Air National Guard. We are landing on airstrips that the U.S. built in the Cold War, and we are taking advantage of U.S. assets. So I don't foresee a Trump takeover of Greenland. That's not what Greenland wants. I don't think that's what anybody wants. But I think we already have a strong partnership with Greenland, and I imagine that the ways that we might strengthen that relationship, I don't foresee any way that would accelerate the melting of ice in a direct fashion by us being there. Again, we already have a strong presence there, and I think both Greenland and the United States would like to strengthen and continue that relationship.
I have one thing to add to this, which has been, I've been thinking about the last couple of days, is that if the United States were to acquire Greenland, are we then responsible for the fate of the ice sheet? Do we take some ownership of it in a perverse? Now, you say, well, global emissions are really what's responsible for melting Greenland. But if the United States were to control Greenland, what are we telling the rest of the world? We're going to let the ice sheet go? I mean, I don't think it makes much sense as a kind of, legalistic thing. But there is this sort of political sense that, hey, are we going to take responsibility for this?
Yes. And again, Greenland is a sovereign country within the Kingdom of Denmark, and there should be no taking over. But I'd like to go to a science question from Kathy Buckley. How much has fracking and its subsequent methane releases accelerated sea level rise? Dr. Duss, how about?
Sure. The question about methane is a great one. So methane is a really, really potent greenhouse gas. It is shorter lived in the atmosphere, so we often tend to focus on things like carbon dioxide and CO2 emissions. But actually, close to 30% of the rise in global temperature since pre-industrial has come from this increase in methane emissions. And something like 80 times more potent in terms of its warming potential than carbon dioxide, but again, has a much shorter lifetime. As you may or may not remember, the very beginning of my presentation, when I sort of showed fossil fuel use over time from my great-great-great-grandparents to the present, we started with things like coal and oil and methane, which fracking has contributed to, really just started to rise in recent decades. So there's no doubt that would have played a role in contributing to the acceleration of warming. Warming in turn is what is driving ice melt as well as this thermal expansion of the ocean. So you can connect the dots in that way, certainly.
And Sarah, there's a question about marine-based methane flux. Would you could you address that?
I don't see the question, but I can sort of talk.
Yeah,
right. So, there's
is.
concern, right. There's methane is held in wetlands. It's in permafrost, and there's actually buried submarine permafrost and submarine methane a little bit around Greenland, but mostly around the Arctic Ocean itself. So all of the coastline, if you imagine the North Pole is a big ocean covered with sea ice, and it has land surrounding it. And so many of the submerged lands near shore there have frozen permafrost. And there is concern both from thawing of land and the thawing of these subsea deposits that you could increase methane fluxes. And that's an area of active research by many.
Okay, great. There was in the hearing yesterday, again, shockingly, in this Senate Committee on Commerce, Science, and Transportation, nothing was said about the rise of the loss of the Greenland ice sheet and the melting sea, increasing sea level. But there was a lot of focus on security. And Sherry Goodman of the Wilson Center has often spoken of or coined the phrase as climate change as a threat multiplier. Rafe, could you speak a little bit about the security aspect of this concept, this misguided concept of the U.S. proposal to somehow have more control over Greenland? What is the real security issue?
Well, I think
thinking about?
No, I mean, I think that the real security issue is derived from sea level rise. I mean, every naval base in the world is vulnerable in a sense. So all the costs of rebuilding and of adaptation of the U.S. Navy are on the table. The movements of large populations away from coastal areas will present security issues. The other irony here is that the issue of security in Greenland is caused by the loss of Arctic sea ice, which allows the sea lanes to open up, right? So there's a lot more vessel traffic of all kinds, which creates the potential for competition and more conflict. And again, there's ironically, that this whole focus is a result of climate change, but Trump thinks it's a hoax still. So there's a certain additional irony there.
Okay. Great question from Tony Beatty from my hometown in Massachusetts. How will ocean sea level rise vary across regions, Dr. Duss? How will desalination of ocean waters affect food supply? How are Greenlanders feeling the effects of loss and changing habitat? I wish we had someone from Greenland, and maybe that can be a future webinar for people to hear from the people from the region. This is more focused on the science and policy, but yeah, what can you tell us about these questions?
There's multiple layers to that question. I'll start with sea level. The ocean is not a bathtub, right? So sea level varies tremendously not just from continent to continent, but even anyone who has lived near the coast in one embayment knows from one storm to the next, you might have storm surge on one side and not the other. So we have this hyper local scale variability in terms of shorter term dynamics, and you have really wide variability on a global scale. One of the reasons that I highlight the East Coast of the United States in my examples is not just because I live here, although that is part of it. It's easier for me to connect to, but it's actually a region on the Earth where sea level is rising more rapidly than almost anywhere else. And that's a confluence of factors. So when we talk about this difference in sea level rise, we're talking about what we call relative sea level rise. So that's how does the sea and the land height change over time? And so you have to think about all sorts of factors. You have not just the fact that you have fresh water pouring into the oceans from Antarctica and Greenland and melting glaciers around the world. You have, again, this expansion of seawater as the ocean takes up all this excess heat. You also have things like changing ocean currents. So when currents slow down, that water can pile up along the coastline. That's also sometimes happens along the US East Coast. You have long-term changes in wind patterns. So for example, in the Pacific coast right now of the United States, you're seeing an acceleration in sea level rise versus recent decades that has to do with these longer term multi-decadal patterns in weather and climate systems. And then you have the land motion itself. So ironically, in parts of Greenland, relative sea level is falling, even though that's where most of the ice is being lost. And that's because as that hyperlocal ice loss is occurring, the ice was so enormous that it was pressing that land down into the Earth itself. And so that land, the island of Greenland in places is sort of emerging. It's coming up as that ice is lost. It has less weight pushing it down into the Earth's mantle. So it's a very complicated relationship between all these things. And it's why it's so important to understand when you're thinking about protection of assets or economies or communities, it's really important to understand how sea level is varying at that local and regional scale.
Great clarifying question and answer. Thank you. And we are getting so many questions. This is excellent. Another science question, and then I'd like to go to some people are asking about sort of policy and actions going forward. A question from Dan Rafe, former colleague at the State Department. How concerned should we be about the impact of the Greenland's freshwater melt on ocean currents? Like in the North Atlantic, are ocean currents likely to change sooner than the impacts of sea level rise?
Yeah, so that's a really important question. It gets at how interconnected all these parts of the Earth's climate system are. We're, many ocean scientists, especially many of my colleagues here at the Woods Hole Oceanographic, are carefully monitoring things like freshwater input into the North Atlantic and how the what we call this meridional overturning circulation. Sometimes people refer to it as this ocean conveyor belt, right? The ocean is not static. It's always moving. It's distributing heat from the tropics up to the poles constantly. It's what keeps Europe livable as opposed to being in an ice chest, which its latitude would suggest. And there is a lot of evidence in the geologic record that in the past, when large amounts of ice sheets have melted, whether it's Greenland or the Laurentide or the Eurasian ice sheets during, say, the last ice age, during rapid melting events, all of that fresh water would be sufficient to actually slow down that overturning, that conveyor belt, which is a really important source of heat to the atmosphere. So it's something that people are monitoring very carefully. There are indications that these currents may be slowing down right now, but there's also a lot of variability in them from year to year and decade to decade. And so right now we don't have a very long observation period, but we're out there trying to make those measurements continuously now to really get a handle on that and understand, perhaps in like an early warning system sense, if there is something being triggered.
Excellent. Okay, there's a question that maybe I will take on, that sea level rise is a security risk, absolutely. But don't you think the security risk, which is why Trump wants, okay, he's referring to the security risk of China gaining access to Greenland and Russia getting access to shipping routes, China and access claiming more power over the sea routes, and isn't that a security risk? So in a way, isn't that a justifiable reason for the U.S. to propose buying Greenland? I just think that these clearly, yes, Russia and China are moving into the Arctic. There will be more shipping activity, And those topics, I think, could be addressed in a much more collaborative way with Denmark and Greenland. So, but we should, yeah, I think we'll stick with more with the science and sea level action questions. One more for you, Sarah. How much of the data shown in the presentations might be at risk of being pulled from public access, or is that an issue considering the current adversarial viewpoint toward climate science in the current administration?
Yeah, that's an important question. And, you know, those of you who are really paying attention may have noticed that I was citing a lot of work, for example, from NASA or the National Climate Assessment work that, you know, I was funded through, for example, the National Science Foundation. And it's, you know, this kind of research is critical to us understanding what's happening and being able to make predictions for the future, so we know how best to prepare and to deploy our assets and our resources. When I give a presentation, I often draw on material I've used before, so I can't say for sure that everything I pulled is still there, but when I went to refresh and update some graphs, I was heartened to see that many of the sources where I would go for information, I did not run into any links or anything missing, so I don't want to make promises for the future, but as of now, I'm happy to say that most of what I use as these important resources is still there and available. I know there are also efforts underway in the policy and scientific communities to be mirroring and backing up a lot of this material. I hope that's just an extra precaution, that we don't need that, but I think it's smart.
I can't speak to the status of all the various websites, but I have heard and read that some of them have been pulled down. They may have been put back up, but it's extraordinary that we even have to think about this, that there are people trying to pull down the fantastic scientific work that's available to people worldwide for reference. I mean, it's appalling.
Which is informing the future safety, health, and security of Americans and global citizens worldwide. But we're getting close to an end, but I have a question from my colleague and a former recent graduate of the Kennedy School. She's interested, she is from the Cook Islands, which is also experiencing a sea level rise. What thoughts do you have about forming coalitions with Pacific Island countries to develop that new metric on sea level rise, or to communicate this at the UNFCCC Conference of the Parties? And what ideas do you have for taking this forward, this idea?
Well, I totally agree. We had some meetings with representatives of small island states up at the UN General Assembly. They are key. I mean, there is a huge alliance to be built with those governments because the fate of those islands is on the line. You know, just like Massachusetts or the eastern part of Massachusetts. So there's an alliance. We need the alliance of the vulnerable to become the voice, or even, how can I say, accelerate, make that voice more powerful. And I think the small island states are well organized. They've been very active. And I think that carrying this idea of an upper limit to sea level rise might help put the whole issue more clearly on the table.
Excellent. What about earlier on, Sarah, you said that it's not too late to change, and you made that point, and also in summarizing. Could you speak a little bit more about opportunities to address this more directly? What about the dicey remedy potentially of carbon dioxide removal? And just if you could just touch on that, because I want to give you each a chance to say something hopeful and encouraging to our audience on how we want to move forward at the end.
Yeah. Well, I can try to combine those two things, because I mean, I am an eternally hopeful person, even in this moment, be that as it may. You know, it's been incredible to see the literally exponential rise in renewable energies, in non-carbon source-based energies that are available to us. They are now the most cost-effective source of energy in the United States and worldwide. I know we have some challenges ahead of us in the next few years, but I really don't see, you know, the whole world is shifting. Our governments are shifting, maybe not federally right now, but at state and local levels. Our businesses, to keep up, are going to have to be making these changes, and we have the resources we need to decarbonize. So, you know, I think some extra political will would be helpful there. Carbon dioxide removal is I think it's going to be an important tool in the toolbox, but it does not a get out of jail free card. There are parts of the economy we can't decarbonize. So it can perhaps be used to sort of sop up that extra, but it should not, in my view, it should not be seen as a real response to needing to really strongly and rapidly reduce emissions.
Okay, and we had a question which is probably too much to get into, but maybe we can come back to that one. Sean Pryor from Clean Arctic Alliance asking questions about limitations and should there be greater limitations on vessels using fuels with lower black carbon emissions, carbon dioxide, and methane emissions. So thank you for that, Sean. Rafe, I'm going to give you the last word, 30 seconds or less, because we're already over time. I want to thank everyone for joining this. Remember that there will be a recording. And Rafe, what are your parting words of wisdom?
Well, my parting words are that we, ironically, surprisingly, we have a great opportunity here to tell the Greenland story like it's never been told, and what's required of all of us to get the situation in hand. And that's the moment we're in.
Okay, that's the moment, and this is the moment to close this webinar. Thank you, hundreds of people from around the world tuning in for this very important topic, and I'll look into posting some more information as we go forward on the melting of the Greenland ice sheet. Thank you so much.